In Chapter 11, we're going to talk about liquids, solids, and intermolecular forces. We talked about gases back in Chapter 5, so now we're going to talk about other states of matter. So we'll start off. I want to show you this video of, I believe he's a Canadian astronaut on the space station. It's pretty cool.
If you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung-out cloth? So, and had to use equipment that was here on board the space station. We might have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's packed in. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Merit and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I fill the water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet.
Isn't that crazy?
Tube of water. The water's all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of doesn't stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is, the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations, great idea.
All the other videos. So, what do you think of that? It's cool, huh? Water doesn't do that on Earth because gravity pulls it down. But what we're seeing there is without any gravity, the water doesn't fall, it just runs along his arm. So what we're talking about in this chapter about the forces that hold particles together, intermolecular forces, explains why water does that. So that was part of my purpose in showing you that video, also because it's just really cool. So intermolecular forces, as their name suggests, between molecular molecules. So intermolecular forces exist between all molecules and between atoms. They are attractive forces, and they are significant only at very short distances. We have liquids and solids because of intermolecular forces. If there were no intermolecular forces, everything would be in the gas state, and the universe would be a very, very different place. Intermolecular forces are very important in physiological processes. Most of the reactions that are going on in your body rely on intermolecular forces for part of that, and the shape of your DNA, all sorts of things depend on intermolecular forces. So, if we think about water's a very common compound, and we're familiar with it in all three states. What determines whether water is a solid, a liquid, or a gas is the temperature, right? If it's very cold, it will be a solid. If it's sort of medium, it'll be a liquid. And if it's really hot, it will be a gas. So the state of the matter depends on the temperature. The temperature is a reflection of the kinetic energy of the particles. So the thermal energy of the particles, and what holds them together is the intermolecular forces. So if the intermolecular forces are stronger than the kinetic energy, it will be a solid or liquid. If the thermal energy is great enough, the particles will just break away from each other and it will be in the gas state. So what state a piece of matter is in depends on the relative strength of the intermolecular forces relative to the thermal energy or the temperature.